Hello, my name is Andrei Hense. I'm Doctor Candidate number 7 of the Innova project, and today I'll give an introduction on how to design a silence, the engineering behind the product design. Do we always need specific noise barriers to reduce noise? For example, if you have a vacuum cleaner or a car that is making unwanted sound and annoying people around and also the user, one solution would be to add a noise barrier around your vacuum cleaner, make a box or construct a wall. But is it always the most efficient solution? Why not make a product that is already quieter? And for one side, you can think about putting the noise barrier inside or mix it to your product. And what are the steps that we need to take to make a better product, a better acoustic performance for your product? First, you need to consider it already in your project. And you need to understand what are the targets, what are the acceptable noise levels for your product, what is the sound quality expected from your customers. And then you need to understand the physics behind the noise. How is it generated? Is it generated in the tire of your vehicle, for example? Is it generated in the engine or by the turbulence of the wind around your vehicle? And how is it propagated from your source up to the receiver? Is it airborne? Is it structural borne? What are the dominance paths that you need to act on? There are some tools that we can use to understand better this source and path up to the receiver. You can go for experimental methods, and that's really good if you have the prototype or your products in hand. On the other side, if you can go for numerical methods that you can easier see the results, and you can calculate many different designs easier or faster, and you can also predict before having your product in hand. There are plenty of methods that you can apply. I'll just give some ideas. You can do a design of experiments where you change your product and you measure the pressure or the vibration of your product, and then you can identify what are the most significant designs that improves or make the noise issue appear. You can also go for more advanced techniques as transfer path analysis, where you can really know what are the dominance paths in each frequency. You can also use array of microphones or intensity probe to identify the location of the sound. Is it coming from the front part? Is it coming from the engine? Where is it coming from? Where is it radiating the most? Numerical methods are really powerful, and the most known are finite element method, boundary element method, SEA, and SCFD. There are plenty of more methods, but for acoustic and vibration, these are the main one for engineering your product. With them, you can calculate the response of your structure, as in the middle figure. You see the mold shape of a vehicle body. You can calculate the radiation of your engine, for example, in a vibroacoustic analysis, or you can also do a CFD calculation to identify the aeroacoustic noise generation around the mirror of your vehicle, for example. You can also calculate the cabin noise, the radiation inside space. In the left, the seats and the walls are not considered, and in the right, you can see that they are considered in the simulation of radiation noise inside a closed cabin. You can also calculate the scattering around the submarine, for example, or the radiation from a vehicle, or the sound pressure distribution around the airplane. So you can use these methods to simulate or calculate the response that you need to understand and to improve your noise. If you want more details, you can give a look in the review on cabin noise simulation framework in the Innova website. And to conclude, some good practices for NVH. For sure, the solutions will depend on each application, but you should always consider NVH in your product development, so it's not too late to implement efficient solutions. Take care with the natural frequency alignment. The natural frequency is a frequency where your component will have a peak response with a little excitation. Avoid it so you avoid resonances. Take care between the natural frequencies of the many components that make your product so they don't match or tune their natural frequencies. Typically, increase the mass will reduce the noise. If you have a panel and you increase the mass, it will increase the transmission loss between one side to the other. If you have a big structure and you make an excitation, it's harder than a light structure. But take care, nowadays we want to design for lightweight structures. Another step that you can take is make some insulation between the source and the receiver, and you can add mounts on your engine, for example. Add damping and acoustic absorption in your system to dissipate this energy. It can be structural, and usually you can use polymer or rubber materials, and in the acoustic domain you can use porous materials. Usually these solutions are called sound package in a vehicle, for example. And for sure you can use noise barriers to improve your acoustic performance. Thank you very much.